Hi, welcome to Francois Maths class. Today we are going to look at the topic coordinate geometry 2, that's which is under circles. And with this, we are going to look at loci, which is the plural for locus. And when you talk of the locus, it deals with the certain conditions within the xy plane that makes the equation true for all positions in the plane. So first, we will look at a question. So the question will depend on the kind of locus that you have. So let's first pick a first question. And the first question is, we are supposed to find the equation of the locus P if it is always equidistant from the point -3, 1 and to -1. So that is our question. We are saying that find the equation of the locus P if it is always equidistant from the point -3, 1 and to -1. So it means that we are saying that the point is equidistant from these 2 points. So if it is equidistant, it means that when you have a line, it means that point, let's say the point is P as xy, it's equidistant. So it means it divides this one into 2 equal parts. So let's say we have our first point A to be -3, 1, and the next point B to be 2, -1. So this one tells you that the distance between PA and PB should be equal. So you have to find the distance of PA, which should be equal to the distance of PB. And to find the distance of PA, we look at this. So PA becomes square root of x minus -3 squared plus y minus 1 squared, which should be equal to the same distance between this and that, which is square root of x minus 2 squared plus y minus -1 squared. So this one, because you have square roots on both sides, the square root will cancel, or squaring both sides, the square root will go. So we have x plus 3, or minus 9 squared, plus y minus 1 squared should be equal to x minus 2 squared plus y plus 1 squared. So we need to expand the sides. So in expanding this one becomes x squared plus 6x plus 9, because you have this one multiplied, you have 3x times 2, that will give you 6x, and this one squared is 9, plus y squared, this time this gives us -y times 2, you have minus 2y plus 1 is equal to, now you look at this side, x squared minus 2x, so times 2 minus 4x plus 4 plus y squared plus 2y plus 1. So after getting this, the next thing is we need to group all of them. So bringing this one here, we have x squared here. This x squared comes here and becomes 0, comes x squared minus x squared is gone. Then the y squared will also go. So this and that is gone. This and that is gone. So we have 6x here. This one coming here is negative, so it comes into positive. It becomes 10x. Then we have, let's consider the y, -2y. This is plus 2, so it comes here, it comes minus 4y. Then 9 plus 1 is 10. This 4 plus 1 is 5. So 10 minus 5 minus 5 is equal to 0. So this one gives you the equation of the locus. but we need to describe it. So to describe this equation of the locus, it means this one is an equation of a line. This one is an equation of a line, which, because with equation of a line, it should be in the form of ax plus by plus c, and this is in that form. So it means we have to really get the gradient and the y-intercept. So to get that, it means you have to make y the subject. So we send this one, so 10x minus 5 is equal to 4y. We divide here by 4, here by 4, here by 4. So y will give us, this goes here, 5 over 2x minus 5 over 4, minus 5 over 4. And this one tells you that this one is the equation of a line. So the locus of P is equation, or a straight line. It's a straight line with gradient. The gradient of this is what? 5 over 2. And the y-intercept, negative 5 on 4. So this is the locus of that. This is the locus of this. Now let's pick another question. Let's pick another question on this and see how we can solve that. And this time our question is, the point P moves such that PA is perpendicular to PB, where A 1, negative 1, and B 4, 1 are two fixed points. Find the locus P and describe completely the locus. So the point P moves such that PA is perpendicular to PB, where A 1, negative 1, and B 4, 1 are two fixed points. Find the locus of P and describe completely the locus. So we are saying that this one is perpendicular. So if it's perpendicular, it means that we have two fixed points. So our first point A has been given us 1, negative 1. And our next point B is 4, 1. And because it's perpendicular, it means that it forms an angle of 90 degrees. So it means it forms this angle of 90 degrees. So we have our P, X, Y. So if it forms the angle of 90 degrees, it means that their gradients, the gradient of PA and PB should be equal to, when you multiply them, you should get negative 1. So when you have PA to the M1, for that as the gradient, so it means our M1 multiply M2 should give you negative 1. So let's find that M1 becomes PA. So find the gradient of M1. So PA, or gradient of PA, becomes, gradient is change in y over change in x. So y minus negative 1 over x minus 1. So it means that our m is equal to y plus 1 over x minus 1. Then we look at the gradient of, so this is our m1, gradient of PB. And that one is, we have y minus 1 over x minus 4. So M2 is giving us y minus 1 over x minus 4. But from that, as we said, if they are perpendicular, it means when you multiply the gradient, you should get negative 1. So we have y plus 1 over x minus 1 times y minus 1 over x minus 4 should give us negative 1. So this one, you can multiply the numerator, y plus 1, y minus 1 is equal to, because multiply negative 1 multiplying x minus 1, x minus 4. So we can open that. So opening this one will give us y squared minus y plus y. So it's gone. Minus 1 is equal to, because this side is a difference of 2 squares. So now this one, we have minus 1 into bracket. We have x squared. This one will give us minus 4x minus x. So minus 5x plus 4. Plus 4. So we multiply 2 by negative 1. So y squared minus 1 is equal to negative x squared plus 5x minus 4. So we send everything here. So send everything here. We have this one going there. We have x squared plus our y squared. This one will go there, minus 5x. Then this one is negative here, going there to be positive. So minus 1 plus 4 plus 3 equal to 0. So this one becomes the equation of the locus. The locus becomes this one becomes the equation of the locus. And if you look at this one is an equation of a circle. This one is an equation of a circle. So if it's an equation of a circle, then we need to get the radius and the center. So to get the center you compare it, do the comparing coefficients. You have x squared plus y squared plus 2jx plus 2fy plus c equal to 0. So when you compare, we can see that 2j is equal to negative 5 over 2 over 2. So j will give us negative 5 over 2. And our f, 2f is equal to 0. So our f is 0. So it means our center c, it will be, c is giving us negative 5. Oh, c, sorry. Because c is negative, j negative f becomes 5 over 2, 0. Then we need the radius. The radius, r is equal to square root of j squared plus f squared minus c. So with this, we have r equal to square root of 5 over 2 squared plus 0 squared minus 3. So r is equal to, this one will give us 25 over 25 on 4 minus 3. 25 on 4 minus 3. So with this, we are going to get r is equal to square root of 13 over 4. Square root of 13 over 4, which is the same as square root of 13 over 2, because square root of 4 is 2. So therefore, the locus is an equation, or the locus is a circle, because it's a circle with center 5 over 2, 0, and radius root 13 on 2. And this brings us to the end of today's lesson. Continue to subscribe to Francois Maths class. Thank you and bye-bye.